So I'd like to welcome Simon Toole, who's going to be talking about FAIR standards for astronomical data.
Okay, so today I'm going to talk about FAIR standards for astronomical data. So I'm Simon O'Toole from AAO, now part of Macquarie University, and in this talk I'm mainly talking about things to do with the Data Central project. And I'd be very remiss to not mention the funding agencies that support us and supported this, the work that went into this. So first of all, what are the FAIR principles? So the guiding principles were set down actually in around 2014 for scientific data management and stewardship, and then published in Nature by Wilkinson et al. In 2016. So you're probably all very familiar with the four key pillars of FAIR, that data should be findable, accessible, interoperable, and reusable. So I'll talk a little bit more about what those principles mean in more detail now. So data is findable. These are the actual principles, so they are a little bit dry, but very basically they're talking about discoverability, how easy is it to find your data, and not just the data, but metadata that describe it, and that these metadata should be rich. They should provide a large amount of information about the data, including things like how it was taken, what it is, and how it was processed. They should have some kind of identifier that's globally unique and persistent, and they should be in some kind of register resource that's indexed so you can easily search it. And so really you can think about this part of FAIR as how easily can your data be discovered. So you'll see a lot of synonyms in this talk just to try and get the point across. Accessible. Now this is something we heard a little bit about accessibility from a web point of view earlier. However, accessible here doesn't mean accessible to someone who has a sensory impairment, but it really means something, some standard way of getting the data. And it may be that you have some authentication and authorization because you're not ready to make the data fully open yet. But at the very least, the protocol and the way that you actually get the data is open and free, and anyone can come along and implement it. And then a key part of this part of the FAIR principles is that metadata should stay accessible even when the data that they describe are no longer available. And this is actually one of the challenging parts of the FAIR principles. So here we have how easily can your data be obtained. They're the simplest way to think about these, as I said, quite dry principles. So interoperable, we hear a lot about this word. This word gets used a lot, but in the FAIR principles, it has a very specific meaning, and that is that the metadata in particular that describe your data use some kind of broadly applicable language that represents it. So something that is used across all of the data sets. So something is only interoperable if everyone is doing it, if everyone is using it. So this language, and then also a vocabulary, and that they follow the vocabulary also must follow the FAIR principles. So it also must be findable, accessible, interoperable, and reusable. The metadata should also include qualified references to other metadata. So that could be within a data set, or it might be across multiple data sets. And this is also one of the challenges that we in Data Central have found. So really this is how easily can your data be compared? Because if you're not using the same language, you cannot compare your data with other data of the same object or the same thing, same things. And then finally, reusable. So this is really where it comes down to having a good number of attributes that describe your data, to make things very, very clear what it is that you've measured, and how, in some ways, you would like people to use it. And then it also discusses things around the usage license. So this could be something like the Creative Commons license, of the various kinds of Creative Commons licenses, but it could be any number of licenses. And then probably the most important, I think, here is that the metadata should include detailed provenance. So how the data was processed, not just I took this data with this telescope, or I took this data, I ran this data through a supercomputer or something like that, but what was done to it after that? Was it processed? Was it analyzed? How did you derive the data that you're presenting to the user? And then metadata should meet the domain relevant community standards. So really, what this thing is not just how easily can it be used, although it is that, but how easily can your data be trusted? Because that is a really key thing when you're sharing data, and you want people to compare your data. Trust is an essential thing, and that's a whole other talk for core trust seal and those kinds of standards. But for FAIR, the reusable part is really about that. So why would you make your data fair? So FAIR principles make your data more valuable. That's a really, really key thing. But my more valuable, obviously, I don't mean a monetary value. I really mean more useful, more and this comes to the comparable as well, I think, and more trusted. If your data is usable and trusted and comparable, then more people will get value out of it. They will be able to compare it with their data. And then obviously, this is in some ways an obvious one, I suppose, but it will be easier to find for all researchers. And this is a key thing. If people can't find your data in a relatively straightforward way, then they're not going to use it. It's going to disappear into the ether, never to be seen again. And then, we all, if you're a researcher and you need to publish papers and you need to get grants, then you need to have your data cited. And this is becoming more of a key thing for data to be cited as well. So it's easier, it's more valuable, easier to find for researchers, and easier to combine and integrate with other distributed data sets, because it's very easy to have data set in one location or in one sort of platform. But if you want to compare it with someone else's data in someone else's platform, then making your data fair is the easiest and best way to do it. And really, it also encourages more people to get involved in STEM. And this is a really important thing in this day and age. And so, for example, if you make your data accessible and easier to find, then you get programs like Zooniverse. You get programs that allow members of the general public to access your data, to find your data. If you go to the Zooniverse website, there are so many programs, so much data that you can find very easily because it is accessible and discoverable. So I'm just going to touch very briefly here on something that the GoFair website calls the FAIRification process, how to make your data fair. And so I find these kind of workflows useful, but a little bit complex and a little bit jargon heavy, because I don't know what a semantic model is. I think of a data model. But really what you need to do is get the data. If you want to make data fair, you get that data, you have a look at what the data is, and then you model it. You create a data model, and then you try and work out what the linkages between the different data that you might have are, and then other data. And then number 5 there is a key thing: assign a license to it so that it can become open, and then you define the metadata. But that's part of the data model to me. And then you deploy it. Very, very straightforward in concept, but can be quite difficult. So really what you need to to do is how well do you understand, what you need to ask is how well do you understand your data? So in astronomy, we've been leading the way in this space for quite a long time. FAIR is in large part addressed by the IVOA, and I'll talk in more detail about that. And particularly if you look at its architecture note. So there is an architecture note that's publicly available, but version 2 is out soon, and that's what you see here in this diagram. And so basically, if you look at the diagram, you see sections that are starting to sound familiar already, because you have a core part of the virtual observatory here in the middle, but around the outside you have terms like finding and using, getting. So this is and sharing. And so these are synonymous with find, findable, accessible for getting, interoperable for sharing, and reusable for using. And this has been the core of the IVOA architecture since day one. So there's a lot of similarities. The one key difference between the IVOA architecture that you see here and the FAIR framework is that IVOA focuses on the processes to move the metadata and the data through some kind of architecture, rather than the properties of the source or data themselves. However, they're so closely aligned that with only a small amount of extra effort, you can make the next step to become FAIR, and I'll discuss that in a little bit. So there are a few specific principles that the IVOA standards don't provide because they're out of scope, and I'll talk about those, or only recently implemented. So just to look at how the IVOA architecture sits on top of this diagram, you have different components. You have data formats and data models, you have semantics, you have query languages, and these are the core things that really help the finding, using, getting, and sharing of data. And so you have a registry that allows discoverability. You have data access protocols that allow the getting of data. And then you have applications that allow you to use it. And you have the actual data itself, the collections of data that allow sharing. And then these are just the protocols. All of the protocols up to now for the IVOA, and you'll hear plenty about that throughout this meeting. Various IVOA protocols, and then if you come along to the IVOA Interop, which is next week, you'll hear even more and some of the details of how to use them and how they're developed. So in brief, the IVOA standards and protocols address all but about 4 of the FAIR principles. It's easier to discuss what they don't cover than what they do, because there's only roughly 4 that they don't cover. And of course, these non-IVOA based principles can still be met. You just need to do a bit more work if you've already implemented a TAP service and a simple image access service and those kinds of things. So I'll skip through these quite quickly. The IVOA standards are mainly findable. The FAIR principles require that metadata are assigned a globally unique and eternally persistent identifier. So IVO IDs, which is a commonly used ID within the IVOA, is not easily citable, and so a lot of people are obviously starting to move to DOIs, and they're not required to be eternally persistent. And this is often a challenge because of funding. It's very, very hard to demand that. Also, the standards don't require that the data identifier be returned in all cases. So if you do a query to an IVOA compliant system, you don't necessarily get this ID, and there's no requirement. And so the principle is really left for the service providers, the people who are implementing these IVOA standards, to decide how they're going to address it, or if they're going to address it. And the standards are mainly accessible. Metadata are accessible. This is the requirement from FAIR, even when the data are no longer available. the IVOA doesn't specify any rules on how reliable a service must be. However, they do provide regular weather reports. If you come along to the Interop meeting next week, then you'll hear some from the operations working group. And once again, this is left up to the IVOA service providers to determine how to manage this requirement. And the standards are basically interoperable. You do have to do a little bit of work here, but it's really once you implement the IVOA standards, you're basically there. You're basically at interoperability. They implement vocabularies, and in particular, they have a language, the universal content descriptors, and there's a version of that that's out, UCD 1+ at the moment, and that means that the principle is fully met. But if you really want to get sort of into the nitty-gritty, then to really meet the interoperability principle of FAIR, you need a cross-referencing framework that goes beyond just the data that you have. So data link in the IVOA is a protocol that basically links data through the metadata within a data set. So you may have spectra and images and data cubes and catalogs that describe an object or objects. But really, in order to be truly fair, you need to have that same data link standard go across multiple data sets and potentially link into other data centers, other places that store the data. And they're mostly, almost, but not quite fully reusable. This is just from a standards point of view. There are no specifications from the IVOA about what license data and metadata should have. But many funding bodies are starting to require or request that groups who are holding data apply licenses to data releases. And for example, our funding, one of our funding agencies is the Australian Research Data Commons, and they are starting to request it, and very soon they'll start to require that there are licenses attached to data before they support any more projects. But it's up to the providers, once again, to determine the best licenses to use. And often this is then pushed onto the data producers. So the survey teams, for example, or the researchers, or the whoever it is that's producing the data needs to decide on a license. And I'll also note that while we now have in the IVOA the provenance data model, the provenance DM, it was only published last year, so there are still many systems that don't yet implement it. So now I'm just going to talk very quickly about a case study, the All-Sky Virtual Observatory, which is five nodes. Part of it, really, this is the Australian Virtual Observatory, and there are 5 nodes: the Murchison Wide Field Array, the Theoretical Astrophysical Observatory, SkyMapper, CASDA, which includes the ASCAP archive, and Data Central, which is the one that we've built, and that includes the Anglo-Australian Telescope archive. Very briefly, so the MWA is one of the SKA pathfinders in Australia. It's a low-frequency radio telescope, and it has, in fact, much more data than this now. They're butting up against their 40 petabyte quota of data. And it's one of it has a very large amount of data, and mainly provides the pre-processed uncalibrated data, but it still runs a TAP service and uses the OBSCORE data model. TAO, the Theoretical Astrophysical Observatory, it hosts simulations for galaxy formation and cosmology. It has over 1,000 virtual universes, and it doesn't really have, it's not particularly virtual observatory compliant at this point. The SkyMapper node is specifically built supporting SkyMapper, which is a 1.3 meter telescope at Siding Spring Observatory. And the goal is to have a digital record of the entire southern sky, multi-epoch, 6 filters processed and calibrated with the data made available. They have a simple image access service, for example, a TAP service, and they have around about a petabyte of data that's made publicly available. and they have a data rate of 100 megabytes per second. CASDA, which is run by the CSIRO, and that is basically the ASCAP, the Australian SKA Pathfinder Science Data Archive. So this is similar to MWA. It's one of the SKA precursors, and it provides science-ready data products. It's been running for a few years now, and they've just had a whole lot more data released, processed data. So I definitely encourage you to check that out if you're interested. And then finally, Data Central, so operated by the AAO, or now AAO Macquarie. We run a lot of virtual observatory protocols, and we also make use of them, not just providing services like simple image access, spectrum access, data link, and TAP, but we actually have applications that consume other virtual observatory services from other systems. We also host the AAT data archive, which has 40 years of data, going almost but not quite back to the beginning of the telescope in 1974. And it's heterogeneous survey data that should be, and we don't just have optical data, but we have a growing amount of non-optical other wavelength data. And we provide API and UI access. So the ASVO, a couple of years ago, we surveyed all of these nodes to try and gauge how well they met the FAIR principles, and we found the results here at this table. And so you see that for most of the principles, we hit them pretty well. That's the Y in this table is yes. The P is a partial or under development. And so here we really see that the main roadblocks for the ASVO nodes are the principles that we discussed, that I discussed earlier, that the IVOA standards don't meet. And that's because most of these nodes actually implement the IVOA standard. So tau at the end here is a little bit different, but they have their own way to be findable and discoverable and meet the various requirements. The interoperability here is really a question of provenance. How well do you track your provenance? And that's where that's under development. And so and some of the data link implementations. But these are well in a way, and they're probably at this point, some of these may be a little bit out of date, in fact, but they're very close. So certainly Data Central now implements UCDs and data link. So the key takeaways from this talk, and this is something that I can't emphasize enough, I've probably already talked about it a fair bit. If you implement the IVOA standards and protocols to provide access to your data, then you'll be almost, but not quite, fair. And then with just a few extra additions, you can become completely fair. So I talked about those, and really they're things that are becoming more standard in a data set. So it's like a key thing is really the licensing issue that I talked about, but also the digital object identifiers. So something that is eternally persistent. A DOI lives forever, even if the data doesn't. So if you define a DOI for your data set or your data, then that will live on even if your data center or the data repository disappears. The metadata that describe your data will persist, and that is one of the thank you. That is one of the key things that make your data compliant with the FAIR principles. And so then let me just go back a little bit here. So yes, and then if you one of the things I think is a challenge moving forward, and this is going to be very difficult, is this cross-referencing framework. So using a protocol like data link, but basically saying, I have this big catalog of data, I need to cross-match it with someone else's big catalog of data. And this is sort of some of the things that we'll hear about at this meeting and at the IVOA meeting next week. How do we go about doing this in a timely manner, particularly because there's more and more data coming online. So you have LSST, you have SKA, these very large data volumes coming in. How do you actually provide this cross-matching and cross-referencing in a timely way? There's some of the challenges that we have moving forward. As I said, licenses, but provenance. And I think provenance is a really, really important thing to cover as well, and especially for the SKA, because the SKA isn't going to store the absolutely raw data as it comes off the telescope. It's going to be pre-processed before it even hits a data center. So understanding the provenance, tracking that is really, really critical to make the data fair. Because as I said, after all, this is really about making the data trustable. How well do you trust the data that you're querying or searching, or how well do you want someone to trust the data? Think about it from that point of view as well. So really, the absolutely key takeaway is to make your data virtual observatory compliant today. There are a lot of tools out there that will make this easy or straightforward. Basically, there are TAP services that you can just download and deploy. Multiple data centers now have implemented their own and make them publicly available. There are simple image access. There are simple spectrum access. So it is now far easier than it ever has been to implement the VO standards, the IVOA compliance standards. So I'm going to end there and say thank you for listening. And I want to pay special thanks to James Tocknell here at the AAO. He was the one who put together a lot of the survey work around the ASVO that I've presented here and was funded by the Australian Research Data Commons. And then, of course, a special thanks to everyone at the ASVO nodes who cooperated with James, took the time to answer some of the questions that he asked around the fairness principles and allowed us to get a good picture. And I dare say there are a few more talks later in the week about fair principles at other data centers, and I dare say you'll hear some familiar things on how to implement and what work still needs to be done. So I'll leave it there. Thank you very much.
Thanks, Simon. So we've got a couple of comments and a question on the live questions. I guess there's a poster about best practices in data publications that is also relevant to FAIR, which you might have a chance to see out here and on GatherTown. And then there was a question by Francois. I'm not sure you addressed it. I mean, by going back to some of your previous slides about for interoperability, do you think better integration of data models in VO service could help?
Yes, I do. These are complex systems now, but I do think that, yeah, I think the data models can provide a lot of help there. I mean, they're sort of the fundamental things that underpin all of FAIR, really, and that's why they live in the VO core. So yeah, I do think that if we have, I don't want to say improved because they're already very good, but if we enhance the data models to take into account some of these the UCDs and that metadata, then I think yes, absolutely.
Thanks. So we are a bit over time, so I think let's thank all of the speakers from the session again.